Hello Year 7s and welcome to our next lesson on fractions. Today we're going to be looking at adding fractions. Quick recap on what we've covered so far with fractions. So you already have these notes in your book. You do not need to copy them. We call the top number the numerator. It's the number of parts that we have. We call the line that separates our fraction our vinculum. And we call the bottom number our denominator. So we can say 3 parts out of 5. We can say 3/5 or 3/5. A proper fraction has a numerator that is less than the denominator. And I'm giving you the example here of 3/5 or 3/5. An equivalent fraction or equivalent fractions are equal in value. For example, a half is equivalent to 2/4. If I multiply my numerator by 2 and my denominator by 2, I end up with 2/4. So equivalent fractions, I must multiply my numerator or denominator or divide my numerator and denominator by the same number. Improper fractions has a numerator greater than the denominator. So the example here I've got is 7/3 or 7/3. A mixed number contains a whole number and a proper fraction. So we've got 7 and 5/8. Okay, that's what we call a mixed number. So we've covered this in our previous lessons. This is something we've done previously as well, but a quick recap because we will be using it when we're adding fractions. So you've already hopefully copied this or printed this out and stuck it into your books. Converting mixed number fractions to improper fractions. So we've got 2.5 and I've color coded the various parts of the fraction so that we can see what's happening. So the first thing we need to do when we're converting 2.5 into an improper fraction is we multiply our whole number by our denominator. So we've got 2 times 2, which will give me 4. I then need to add my original numerator, which is the 1, to the newly calculated 4. So 4 plus 1 will give me 5. So what does that give us at the end? Well, 5 becomes my new numerator of my improper fraction. My denominator remains the same, which is 2, as we can see. And this image down here will hopefully help us see that 2.5, and I've shown it here with half pizzas, is the same as 5/2 or 5/2. So these are actually a mixed number shown as an improper fraction. Converting improper fractions to mixed number. So we're going back the other way. Again, this is something that you should already have access to. Hopefully you've copied it into your books or you've stuck it into your books if you've had access to a printer. This is an easy conversion because we look at our numerator of our improper fraction and just divide it by our denominator. So 10 divided by 3 is what we're doing here. Now, we know that 3 times 3 is 9, and we're going to have one remainder. So 10 divided by 3 would be 3, remainder 1. The 3 becomes our whole number, part of the mixed number, yeah? So my whole number is 3. My remainder is my numerator, and my denominator remains the same as it originally was. So we know that 10/3, in this case we've got 10 pieces of pizza, each of them is 1/3 in size, is equal to 3 1/3, which is 3 whole pizzas and 1/3 of a piece, 1/3 of a pizza. So adding fractions. We've seen this before, it's a fraction wall, and I'm just going to use it again today to try and introduce adding fractions. So we looked at equivalent fractions last time and I showed you the half. Now, what do you notice when adding the fractions below? I want you to have a look and see if you can pick up the pattern. So we know that 2/4 is a quarter, I'll say that again. 2/4 is equivalent to a half. We know that 3/6 is equivalent to a half, 4/8, 5/10, 6/12. So these are all equivalent to a half. Now there should be a bit of a pattern that we can see in these blue rectangular sections. A quarter plus a quarter equals 2/4. Okay? A 6 plus a 6 plus a 6 equals 3/6. Basically what you should be able to identify is that my denominator, when I'm adding fractions, remains the same in my answer. So if my denominator is common, it remains the same in my answer. The only part of the fractions that we're adding is actually the numerator. So I've added my numerators in all of these examples here. So when adding fractions with the same denominators, we only add the numerator. So these are some rules when adding and subtracting. Now I know we're looking at adding fractions today, but the rules are the same. So if you put this in your book, in fact, I've actually put a handout in the same place where you access this video. You should find a handout which actually says rules when adding or subtracting fractions. If you have access to a printer, please print and stick it into your workbooks. If you don't, you'll have to copy these into your workbook. So my first rule says that fractions must be in proper or improper fraction format. So mixed number fractions must be converted to improper fractions before adding or subtracting. Now some of you may have in the past, possibly at primary school, added and subtracted mixed number fractions. But because we're doing this remotely, I thought it's probably the safest way is for those that aren't familiar with how to do that, is that maybe you can convert everything to a proper or an improper fraction format first before we actually do addition. I think it's probably a safer way to do it. Rule number 2, fractions must have the same denominator to add or subtract. So fractions have different denominators. They must be changed to have the same denominator before we add or subtract. What are we actually doing? We're finding equivalent fractions, okay, with the same denominator. Whole numbers can be converted to fractions with a denominator of 1. So, for example, if I want to convert 4 into a fraction, I can say that it's 4 over 1. And I can do that with any whole number. If I put it over 1, it's a fraction. It becomes a fraction. When adding or subtracting fractions, we only add or subtract the numerator, okay, because the common denominator remains the same. So I showed you that when we did the fraction wall, and we'll do some examples to help you. My last rule, which is very important, is simplify your final answer. For example, my final answer was 18/24. I need to simplify that. What can I divide my numerator and my denominator by? Must be the same number. In this case, if I divide by 6, 18 divided by 6 is 3. 24 divided by 6 is 4. So 18/24 is the same as 3/4. Or, if I had an improper fraction, so 25 over 2 or 25 halves, I can convert that to a mixed number. So 25 divided by 2 is going to give me 12, because 12 times 2 is 24, remainder 1 over 2. So 25 over 2 is the same as 12.5. So if you haven't got access to a printer, please pause and copy this into your books. And I'm going to move on. So adding fractions, and a couple of examples for us. Now I've actually got a new tool, so I just need you to bear with me while I use it. Okay, so this is something very similar to what you're going to get when you do your maths-based task. And it says, evaluate 1/11 plus 9/11. Now the word evaluate, let's not get confused by it. When it wants us to evaluate, it actually wants us to perform the calculation. Now, what I'm expecting from you to do is you would write this into your workbook. So I've got 1/11 plus 9/11. And I'll just double check the rules. First of all, they're both proper fractions, so that's fine. Secondly, they've both got the same denominator, so that's fine. I can now follow my third rule, which says I just add the numerators. So maybe if we put our denominator straight in, because it's common, we know it's going to be 11. And then I say 1 plus 9 is 10. 10/11. Can I simplify that? No. There's nothing that I can actually divide my numerator and denominator by that would help simplify that, so I'll leave it as it is. Evaluate 3/8 plus 3/8 and simplify your answer. Now again, evaluate means calculate. Okay, so evaluate means calculate. In this case, it's prompted you to simplify, but you need to simplify even if it doesn't ask for it. So what would I expect you to do? Again, I'd expect you to write this into your books. So I'd have 3/8 plus 3/8. Check my rules again. They're both proper fractions. They both have the same denominator. So now all I need to do is add my numerator. So I might as well put my denominator in because we know it's going to be an 8. 3 plus 3 is 6. Is this my final answer? No, because I need to simplify. My fourth rule states that I should simplify. Because these are both even, I always think of my 2. 6 divided by 2, and 8 divided by 2, which happens to be the highest common factor for both. So we've got 6 divided by 2 is 3, 8 divided by 2 is 4. So this is now my final answer, okay? And that's what you'll be expected to enter into MathSpace. I suggest you actually pause and copy these examples into your workbook, please. Moving on. So next example, I've got 6/7 plus 1/14. Again, I'd expect you to write this into your workbooks. And then I would check my fraction rules when I'm adding fractions. What do I need to do? So they're both, in this case, proper fractions, but my denominators are different. So I need to think of my lowest common denominator. What could be common to both of these? Well, my lowest common multiple would be 14. So I need to change this 7 into a 14. So if I multiply this by 2, I can then multiply this by 2. So now I end up with 6 times 2 is 12, and 7 times 2 is 14, plus this fraction remains the same, no change. Now I already know that my denominator is going to be 14, so I can place that down here. I need to now add my numerators. So 12 plus 1 gives me 13 14ths. Again, I can't simplify that. That'll actually be in its most simplest form. 13 14th is my final answer. Evaluate a quarter plus a third. So same deal, I'd write this into my workbook. Sorry, you've got a quarter plus a third. They're both proper fractions, so rule number 1 is met. I need to find my lowest common denominator. Now I do know my multiples of 3 and 4, and it's going to be 12. So to convert 3 into 12, I need to multiply it by 4, which means I must multiply my numerator by 4. If I want to change 4 into 12, I need to multiply that by 3, which means I need to multiply that by 3. So I end up with 3 over 12 plus 1 times 4 is 4 over 3 times 4 is 12. So they're both proper fractions. They've both got a common. There's a common denominator, so I can put that in straight away. And now all I need to do is add my numerators. 3 plus 4 is 7. Cannot simplify that any further, so 7/12 is my final answer. Next question, I have to evaluate. I've got 1/12 plus 1/9. So 1/12 plus 1/9. They're both proper fractions, so that's good. I need to find the lowest common denominator. Now, if I know my 12 times tables and my 9 times tables, I know that 12 times 3 is 36, and I know that 9 times 4 is 36. So, if I multiply my 12 by 3, I need to multiply my numerator by 3. If I multiply my denominator by 4, means I need to multiply my numerator by 4. So my newly formed fraction will be 3 over 36 plus 4 over 36. Common denominator, so that's going to be my answer for my denominator, and the answer in my denominator, the denominator for my answer will be 36. And then I can add my numerator. So 3 plus 4 is 7. Now, can I simplify that? I know that there's nothing common. I can't simplify that any further. So 7/36 is my final answer. Okay, now we're getting into something a little bit different. I've got 9/4 plus 5. Now, if you remember in the rules, I said to you that we can convert whole numbers into a fraction. All we need to do is put it over the denominator of 1. Very simple. So now in this case we've got improper fractions, and that's fine, but my denominators are different. I can change my denominator of 1 to a 4 if I multiply by 4, multiply by 4. So now I've got 9 over 4 plus 20 over 4. Straight away I can enter my denominator for my answer. 20 plus 9 is going to give me 29. Now I can simplify this a little bit further as a mixed number. 29 doesn't divide into 4, but if I know my 4 times tables, I know that 7 times 4 is 28. 7 times 4 is 28. So 29 divided by 4 will be 7. I have 1 remainder, and I keep my original denominator. So 29 over 4, or 29 quarters, is going to be 7 1/4. That's my final answer. This is probably going to be as tough as it gets, and we'll do this one. Now we're not using calculators again all the way through this, so I would write this out. Now maybe what we could do in this case is I'd write it into my workbook actually, exactly as it is. I've got 5 6/7 plus 3 2/4. First thing, I need to get rid of my mixed numbers. I need to change them and convert them. So the way that we do that, I'm just going to put the extra step in. I would multiply my whole number by my denominator plus the numerator, all over 7. Same thing here, my whole number multiplied by my denominator plus my original numerator, and all that's going to be over 4. From our BODMAS or BIDMAS, we know that multiplication takes place first. 7 times 5 or 5 times 7 is 35, plus 6 is 41 over 7, plus 3 times 4 is 12, plus 2 is 14 over 4. Now my lowest common denominator between these two. Now there is a bit of a trick as well that we can use. If you weren't too good with your times tables, if you actually multiply your denominator for this fraction by both our denominator and numerator, and do the same thing, we use this 4, multiply that by 4, we actually end up with a common denominator. So a couple of little things. These are quite, well, first of all, we can actually work out our denominators. So 7 times 4 is 28, plus 7 times 4 is 28, so that's good. But we need to work out this bit here. So I might just do a bit of a calculation and just show you what I'm doing. I've got 41 times 4. 1 times 4 is 4. 4 times 4 is 16. And I need to do 14 times 7, which is this calculation here. 7 times 4 is 28. Carry the 2. 1 times 7 is 7, plus 2 is 9. So I've got 98. So this becomes 164, because 41 times 4 is 164. 14 times 7 is going to be 98. Now I need to go ahead and do the addition. So the way that we would do this addition is, I would actually set it up as an algorithm. First of all, we know what our denominator is going to be, so we can put that in there. But I'll do the addition as an algorithm. 164 plus 98. So 4 plus 8 is 12, carry the 1. 9 plus 6 is 15, plus 1 is 16, carry the 1. So I've got 262. Now this is quite, I guess, a larger number, larger fraction. Now how would I go about doing this? We're not using calculators, so maybe the first thing I would do is actually divide by 2 and divide by 2, because I need to simplify it. So half of 262 is 131. Half of 28 is 14. So I've got that. The next thing I should do now is change this into a mixed number. And this is where we need to think a little bit about some of those shortcut maths tools that we learnt earlier in the year. So how many times does 131 go into 14? How many times does 14 go into 131? So 131 divided into 14. So a bit of a tricky one for us, and maybe the way that I would think about it is, if I said, what's 14 times 10? That would be 140. Now we don't have 140, we've got 131. So that means that if I said 9, well, we can just check that. 9 times 4 is 36, carry the 3. 1 times 9 is 9, plus the 3 is 12, so it's 126. Okay, so it looks like I can actually convert this to 9 as my whole number. My remainder, I've got 131, take away 126, which is going to give me 5. Over 14. Okay, so this is our final number, our final calc. This is a little bit of a tricky one for us, and I can appreciate that some of you might see these numbers as quite large, and they are a bit of a challenge, but nothing on this page has been something we haven't covered in the past. Okay, so we've done division, we've done algorithms for addition and multiplication. If we follow the steps, you're not going to be able to do these questions in, 1 or 2 steps. You do need to sort of write out a few steps, have a little bit of working out somewhere as well, and that's the way that we'll actually be able to do this correctly. Thank you.